All right, welcome everybody. If everybody's about ready, I'm going to go ahead and get going. I know some of us want to get out to a party later, so I'm going to begin pretty much on time. Thank you. I'm very pleased to have this opportunity to review some of the most recent attack trends that we've seen in our security operations centers and recent attacks for our customers in the security operations center. This is our beautiful, sunny Fort Lauderdale flagship location of our security operations center in Fort Lauderdale, Florida. My name is Timothy Cookler. I've been with Westinghouse Security. I was at Brinks, and now I've been with Akamai for more than 11 years, 11 and a half years, 12 in February. The majority of that time, I've been supporting and mitigating attacks for our customers, either directly or managing teams mitigating attacks. So I'm the manager of the Cambridge Security Operations Center, one of the 5 global security operations centers such as this one that we have throughout the globe. We are proud to be fighting on behalf of our customers. As you look at this overview for what we're going to talk about today, I am going to review some of the most recent attack trends and what we're seeing in the SOC. But the most important part about this is what I want you to know what you can do as administrators when you go back to your companies, what you can do working with attacks and working with us or your security provider back and forth to make the mitigation for attacks go really quickly and smoothly. I'm also going to talk about things that you can do preventatively so that you'll be prepared when those attacks come in, be able to either prevent them or work really quickly when they do come in. So I'll talk about that. There's certainly some self-service about things on Luna. Of course, some of the things that Akamai can do, of course, I'll talk about the Akamai Intelligent Platform. Plenty of things you can do yourself there. And I'm going to finish up with a brief walkthrough about Security Monitor. With Security Monitor and Network List and other tools, you can self-mitigate your own attack just as we would in the Security Operations Center on our Intelligent Platform. And I'll even do a quick walkthrough of our API. We do have an API for cloud security now, which is really cool. We've got several customers using it now, and I bet by the end of the year we'll have more than 100. So I'll cover that briefly. I know some of you are developers. You'd be very interested in that part. Let me go back. I'll take questions at the end, but I'm also very active in the cloud security area of Akamai community, so feel free to reach out to both myself. I'll be happy to answer questions, and to each other, right? We need more friends and less enemies, so please join our cloud security discussion online. So I want to talk about some recent trends. And so I'll start by telling a story here. So back in the summer of 2016, the largest attack we'd ever seen to date was a DDoS attack that came. It was pretty large. It was 363 gigabits per second. Gigabits per second. That's a huge amount of ingress. It's 57 million hits per second. That's a large amount of volume coming in. It was a huge attack. It was the largest one we'd ever seen to date. And then, a couple months later, I'm down here in Fort Lauderdale in this nice, you can see this nice subdued lighting with the big bright screens there. And in the back, those screens on the top are our border routers, and we can see the traffic going up higher and higher, 400 gigabits per second, 500 gigabits per second, over 600, it ended up being 622 gigabits per second. That's just huge. This, of course, was the Mirai botnet. This was an attack that leveraged multiple vectors and leveraged the Internet of Things. And that's the IP cameras, that's the security cameras that people have in their homes that are on the Internet, applications, DVRs, video recorders, that sort of thing. And they were being taken over and leveraged by the Mirai botnet and then operated by bad actors. So that was pretty good. This is a huge trend. This is a huge attack. We're not going to see it go away anytime soon. I'll talk a little bit about Mirai because I think it's quite a flexible tool, and it is, unfortunately, very impressive. It's very complex. It attacks multiple ports. The vectors that it attacks are all the vectors. It attacks layer 4, attacks layer 7, it attacks DNS. And the operators are sophisticated. They've done their research. They're able to morph or pivot the attack to attack specific things about their customer. And they seem to do it really quickly, like they've done some reconnaissance ahead of time. So not only is the tool pretty adaptive and powerful and widely dispersed over multiple IPs, but also the attack operators seem to be pretty savvy. And they know what they're doing. And it makes it a battle for us going forward. I think this kind of attack is not going to go away anytime soon. We released a threat advisory for Mirai, we released it as a high-level threat when it first came out. We've since lowered it to a medium-level threat advisory, and that's because much more is known now. It's been several months since Mirai was leveraged in this huge attack. But these devices, these are security cameras in people's homes and in gas stations. If you and I have a vulnerability on our Android or on our iPhone or something, we're probably going to patch it pretty quickly. Certainly, this laptop gets patched very frequently. But as you can imagine, a security camera, if that's installed, there are 8 security cameras in a gas station. That gas station operator is probably not very incentivized to hook up a custom cable and do a patch if he's even aware of it. So the vulnerability that exists, even though it's been exposed, is not going to be patched out there in the wild for quite a while. So the Mirai attack network is going to be with us for quite a long time. We saw this huge amount of volume coming in. The software was released into the wild, and other operators began using it. So we have seen some dilution of the victims because you've got those botnets, and now several operators began using it, and so the attack per victim was lower. But I think this threat is pretty complicated and complex. I think the operators are smart, and I think the attack vectors that they're utilizing is not going to go away anytime soon. The federal government got involved. They started chasing some of the command and control centers for that. But again, the vulnerability is still going to be out there. It's just not going to be possible to knock them all down. And certainly some of those IP cameras aren't even patchable. It's hard-coded things. And the ones that are probably not going to be patched anytime soon. So up here I mentioned some recent attack trends, the 363 ones we saw last summer, the 622 Mirai botnet. And then most recently, just a couple months ago in August, we saw the mobile devices start to come in. We had a huge attack on one of our customers. And this was the WireX attack. This was a vulnerability that was discovered in some, well, I'm sorry, it wasn't a vulnerability. There were applications that were hijacked with code that would run as WireX in the background. So you think you're using Stargazer or something on your Android device and you're using Stargazer and maybe it's not so good or what have you. Meanwhile, in the back, there's a headless bot running. It's a full web browser, and it's got all the intricacies of a web browser. And some remote operator is using it headless. You have no idea that's happening. You're a victim yourself. And this happened across many devices. The operators of these attacks were doing something a little different. Instead of, hey, I joined Akamai back in 2006, and back then we thought a T1 was a big pipe. If you were being attacked with T1 bandwidth, that was huge. This bandwidth is out of this world. It's way huge compared to that. So you're seeing a trend of much more bandwidth, right? In addition, we're used to seeing a smaller group of IPs, maybe 100 IPs, maybe 1,000 IPs or something, all attacking us at once. And on a DDoS attack, it's usually a lot of volume at one time. But with WireX, it was only 1 or 2 attacks per second, but it was spread across many devices. In fact, in an hour, look at this. This would be normal traffic right here. Maybe 10, 20, 30,000 different IP addresses per hour. And as the attack operator ramped it up, 40,000. This is double. This is double the amount of traffic that they were getting. So that's a large attack. This is immense, and that is hugely immense. It went up to over 120,000 different IPs inbound every hour. So definitely a widely dispersed attack. This is a good example of our SOC getting involved, working with our internal. We identified that it was mobile devices. We worked with both our SOC, got our CERT team involved. We worked collaboratively together. We happen to use an internal tool called EXA, where we have an advanced detection and spread across over 100 servers to do some advanced detection on the user agents. And we were able to knock this attack down. But the reason I wanted to talk about this is because it's again to the trends. The attack operators are getting more and more sophisticated and spreading the attack out across many different IP addresses. Ongoing, our Akamai SOC sees 30 to 35 coordinated attacks a day, so it's hundreds a week. We're seeing so this is the trend that's over time. The wider scope of destination geos. So the other thing is in the past we saw that a lot of the destination attacks were to the United States targets. And if you don't know why that is, it's because we're horrible at patching our stuff in the US. So we see a lot of attacks to USA attack destinations. This is the most recent one where we're seeing a more widely dispersed. So we talked about, when I talked about the Internet of Things and the cameras, those are devices coming inbound, so the source of the attacks. These are the destinations, these are the locations of the victims. So it's being more widely spread geographically. I've got a much better, hey Mingo, I wasn't able to, is Mingo here? Nope. We also have, if you go down to our booth downstairs in the SOCC, you'll see a live updating version of this, updated to the hour, that shows our most recent attack trends. Also, what is being attacked? Is it SQLI? Is it cross-site scripting? Is it something else? It's live downstairs in our SOCC booth right now. On the left-hand side, you see a great 3 different charts about this and breaking it out in different ways. It's pretty good. For web application attacks only, so this is just the web ports of port 80, 8080, and port 443 secure web. You can see the SQL injection still remains a huge attack vector with large file includes and cross-site scripting being close seconds. So this is web application for those of you who are in e-commerce. And then this is just for those ports, but for all ports, these are the attack vectors across all the ports. Now this chart you can download. We publish this 4 times a year quarterly at stateoftheinternet.com. Feel free to download it. This chart is from our security State of the Internet report version of the Internet report. And it shows the different ports, right? These are the different ports and services across the top with the different colors showing the attack frequency vectors that have come in. Now, you probably noticed that so before 2016, before this, it had gone up about 75% year over year to 2015 to 2016. And then since 2016, it's actually, you can see it ebbs and flows a little bit as things go on. But in an average, it's kind of slowed down a little bit. This is advantageous to us because in the SOCC, we're still mitigating attacks and jumping on them. As our tools are getting better too, we're being more efficient. But it allows us to be more relaxed and to be more consultative with our customers and partners and work collaboratively with them, not only just tamping down attacks, but also we're able to offer recommendations for proactively keeping attacks out and adjusting their security posture. I want to talk about these ports a little bit, though. Look at this one here. This is UDP, right? This is the largest attack vector. I'll show another slide from the State of the Internet report that shows that a little better. But that's a large vulnerability. If you're in e-commerce or you have a specific data center that's doing a specific function, I would hope that you would know whether you're using UDP fragment or not. If you're not, why not shut the port off at your firewall? These would never come into you at all. That'd be great, right? If you're under attack and the attack operator is using any kind of a volumetric DDoS attack, maybe saving that kind of bandwidth would be the difference between the continuity of your business and it being DOSed. Look at, let's see, what's this top one? Look at ChargeN, 10%, right? ChargeN is a 21-year-old service protocol. Is anyone in this room using it? Probably no one, right? So I mean, consider, so this begins to talk about the second part of my presentation, which is I want you to know what you can do proactively about reports. And one is, know the services that your data center uses or your company uses, or if you've got a web service or e-commerce, know exactly what services are being consumed and what you need to project out there on the internet. If you don't need them open to the internet, why not consider closing them down if you're not using them? Look at, what's the second one? Look at NTP. Look how large NTP is here. This NTP, so, okay, NTP is probably important internally as a client, but do you need to service network time protocol out to the internet? Probably not. So consider a proactive stance. Let me show this on a different screen. This is also from State of the Internet report. You can see how large UDP is here. So these are the attack vector frequencies from our most recent quarter, Q2. So the reports are 1 month, 1 quarter behind, more or less. Look how large the UDP fragment is. So if you're not using UDP fragment as a service, consider shutting it down. And the second thing you can do is not only shut down your firewall, but many of your ISPs offer for free a number of lines, such as 50 lines, that you can utilize. Consider moving that up out of your data center completely. Call your ISP and work together with your ISP and block them from ever coming in. So if these attacks come into our SOC, we'll definitely work with you and we'll help tamp down that attack. But by that time, it's already possibly impacted your business. You might have experienced a slowdown of some kind. If you're not going to use, if you know your ports and protocols that you're using, consider pushing them out of your data center and never seeing them, and considering that part of security a little proactively. So I think that'll make a great stance. There's ChargeN, 10%. UDP. Some of the UDP is certainly important for voice communication, but if you have an e-commerce and you have an e-commerce only data center, why do you have UDP open? Just block it at your firewall or push it up to your ISP completely. Okay, next. So the first thing you can do is be aware of what services and protocols you can push off to your firewall and block them, or push up to your ISP. The second thing you can do is have a pretty good idea of your infrastructure. One of the things that speeds your response with us, if you're working collaboratively with us and you call into the SOC and we've identified a particular IP, we may ask you, what is that IP? Do you know what that IP does? Is it important to your business? And you'll need to have that information readily available. This is just an example of from TechNet, from our partner Microsoft Azure. This just happens to be a spreadsheet with a JSON overlay that shows all the servers on a particular example. You can download this. It's free from TechNet. As this person clicks around, so this is called the Data Center Extension Reference Diagram. As you can see, when this operator is clicking around this screen, you can see the details over here change. The host names will change, the IP will change, how the server relates to other servers. There's a button here for more information. So this is a really good tool. I'm not saying you should use this tool, but just have a good awareness of your data center. Every device, not only every device on your data center for web, but remember things that are related. DNS services for the green line or something. Consider everything. You want to also know how this connects to your upstream ISPs, and if you click on those, you want to be able to have their support numbers come up. If there's an account number that's pertinent or a security code, you want that there. I mean, use whatever tool you want, but make sure you have that information. And the reason I bring this up is the SOC prides itself in being able to respond really quickly, doing packet analysis and issuing an ACL or otherwise tamping down an attack. We want to partner with you. We want to work really quickly. So we need you to have that information. If we do all the right things and then it's Sunday morning at 3 a.m. and you can't get a hold of someone because you don't know who operates this particular server, you need a way to get that information quickly. And waiting until an attack is isn't the most speedy way. So the second way is, I would say, know your systems really well. All the phone numbers, including who to call upstream and downstream from you, would be the second thing. So we have that information. Consider also, if we ask you about an IP and we want to block it, we want to make sure that we're not blocking a critical piece of infrastructure, your DNS server. If you know that's your DNS server, maybe we'll look a little bit up or downstream from it, or do some other kind of mitigation rather than block that. Finally, there's a lot of servers. What's critical? Is all of this critical to your business? I want your business to be continuously up. But what if there's a large-scale attack and you call into the SOC, and what if we need 10 minutes to get a hold of it and get a better understanding of the attack? So we'll want you to identify, you'll definitely want to know what is super critical to your business. Maybe you have an FTP server, maybe you have an email. Maybe email, though, can be shut down for 10 minutes or 30 minutes. Email's important. I'm not saying that's a great idea. But if you're an e-commerce company, certainly your web server, your application server, your database server are critical to the continuation of your business. Maybe email can wait 30 minutes. So if you know your critical infrastructure, then maybe you can work with us through a 3-phase attack on a large attack. So here are typical phases of attack mitigation as an explanation of that. During phase 1, then, you may tell us, hey, keep these, I've got 100 servers, keep these 5 servers up. It's okay to block the rest. Go ahead and do it. And we might do that only as a phase 1. Again, it wouldn't be ideal, but we might want to do that just so we can get a further understanding of the attack. In a phase 2, we might understand more about it and do some more of a custom rule, and that would allow us to loosen up those controls a bit and maybe expand out in phase 2 to 30% with of course some retuning, and with the idea to have your entire data center, all the servers and services back up. But critical to this working and staying in partnership with us is you'll have to know what is critical to your infrastructure, and waiting until an attack event happens is too late to have those conversations. So I challenge you to go back to your groups and ask, what's your business continuity plan? Do you have this well documented out? Do you know what portion of the servers are critical and which ones are they? So this will speed your conversations with the SOC if anything should happen. So that's sort of what you can do. What Akamai can do, of course, is if you're leveraging the Akamai Intelligent Platform, we've got that tremendous caching ability on the edge, where we can cache all that cacheable data on our edge servers and serve it right to the users locally, keeping all that data far away from your critical infrastructure in the first place. If you're fortunate enough to be using Akamai's web application firewall, when that WireX attack happened with 120,000 servers an hour being attacked, it sure was convenient that the SOCC was able to push out and adjust a web firewall, application firewall rule on 240,000 servers at the same time in a single production push. I would say that was critical to that success. Tiered distribution parents and network storage, of course, keeping that data still even further away from your data center. Don't forget DNS. We have our fast DNS solution, but I just encourage you to use any DNS solution, really. Fast DNS, I happen to think, is beautiful because it allows you to retain control while having control of a master server that only you own. And we just serve out copies of it using any IP anycast locally to the servers in a really fast way. I think that often we talk about web going down, and we forget to talk really well about bolstering that DNS posture. So that's web, and for ports that go beyond web, of course, Akamai has had a merger with Prolexic 4 years ago now, which allows us to have scrubbing centers which can cover all ports and services, just all of them, and route those through BGP announcements through our scrubbing centers. And that's where our SOCs, packet ninjas, really get on there really quick, and they can look at anything and implement ACLs and do other fancy mitigations. This was where I was talking about. It was very convenient to be able to call in and implement an attack out on all those servers at one time. In addition, Akamai is uniquely positioned, right? We got a unique position where we're servicing all of these IPs across a huge wide swath of the internet, and we're able to gather data on those IP addresses with regards to how risky do they seem, right? We'll assign them a risk score because this client performs 4 SQL injection attempts across one application. This client performed 12 cross-site scripting and SQL injection across 2 different applications. So we're able to, per IP address, we're able to assign them a certain risk score, and we collect all this data and we share it out with you. Our customers that have client IP reputation are then able to decide. This customer decided they wanted level 5, something to happen on level 5. So there's a 0 to 9 reputation score assigned. This customer decided at 5 they would, it doesn't say, but so the customer could alert at 5, or they could say, hey, if someone's calling in with an IP reputation score of 5, or let's say 7, or whatever that customer decided, you could choose what happens at that level. I think that's really good. For security monitor, so I want to show this, but you can do this as well. If you've got security monitor, if you've got web application firewall, you can configure alerts that come to you. And I'm going to show you this because this is part of what our SOC guys do. They go through an attack that might come in for our customers, and they might go through, figure out some details about it. Now, I'll go through this slowly, but I had my specialist do this whole thing and block an attack. It took him 44 seconds. Now, he's an experienced specialist, 5 years to seniority, so I mean, he knows what he's doing. But 44 seconds, you can do it really quickly. And the reason I want to talk about Luna here is because, I mean, hey, 2006, I was fighting attacks, but I was doing it using VI on the command line, and I was using a back-end script to push it out to the network. It's a lot different than today. We used to use grep and awk and sort, really complicated awk and sorts from the command line, and it's really. It makes me proud to see that the tools that we would use, engineer would come by once in a while and ask us what we were doing, and we'd see over time that those tools were put into something beautiful and put onto Luna, and then shared out with our partners to be able to use via self-service. I like self-servicing stuff. I know you guys do too, so I think this is really good stuff, and it ends up being faster than me doing it through command line. This is an example of an alert that comes in. An alert was configured. An alert comes in through the email address. There's the portal link. The user could just click there to see the alert. This is the alert. It would bring you to here. On this screen, you could see these are 2 alerts that had fired. Over here is the time data that happened recently. Now, this is a testing account, so there's not much data here. You can get to this same screen by going to config monitor and security monitor. But of course, it's easier just to click on the link from the email, and it brings you to this screen here. So there's 2 alerts that fired. This is unfiltered currently. There's a little funnel at the top there you'd want to click, and it would show, it would start to apply filters here to match only that alert detail, and then you'd want to click on the timeline there to match the time to it. Sorry, this is a recording. I don't know what Jason's doing here. Okay. So here he'll click on the funnel if he hasn't already, and then he'll click on the timeline. And what this will do is this will change the data that comes up in our stats by boxes. There's 4 of these, 1, 2, 3, 4 down here that are off the screen that you can't see. And as soon as he applies the filter by clicking on the funnel, the data will come up here. And then in each of the stats by boxes, you can sort by different things using the drop downs. It comes up by country and rule ID and stuff. You can see data start to populate here now because he's applied the filter. You can also, so he's clicked the timeline, but you can also drag across and select a wider swath. And the reason I show this is because our specialists don't like to see only the alert data. They kind of like to see what happened before that a little bit. So they tend to do the manual drag thing. So they can see what happened before. They can scroll back in time and see a little trend. So I would say a trend is that we look back at least 10 minutes before the alert to see what happened there. OK, so then these are our stats boxes, right? They come up by country, rule ID, and message and tag. We usually do change these. So if you click on this dropdown, you can change to any of these things in any of the 4 stats boxes. And this is what enables you to really drill down an alert super quickly. As I said, Jason would do this in 44 seconds or so. You can choose any one of these. So he's sorting by client IP, which is very useful. URL is the host name and the URL path. The URL path is the path only in case the host name is varying, which is a good way to do it. And then here, Jason likes to choose the rule or the policy ID. And that's so that he can later use this policy ID in a blocking using Security Monitor's WAF and push it out to production. He'll use that policy ID to apply the rule. So that's pretty quick. Now in our example, we only have 1, but this is really useful when there's a bunch of IPs. You can sort it different ways. You can easily see what's happening here. This is a chart view if there's a dot. Okay, it would be great if there's a real attack. There'd be a nice curve that you'd see exactly what's happening. You can get a table view, and you can even download the data into an Excel spreadsheet if there's a lot of data and you wanted to share it out to another department or something. You could certainly do that. So policy ID. This policy ID is 23852, ends in. So you can change any of these, and you can apply the filter. If you apply the filter in any one of the stats boxes, it applies the filter to everything. You're able to see it. You can also see raw data here, which is cool. If you want to see some of the raw data, rather than call in the past, you used to have to call into Acatech or customer care to get get logs and ask us for logs, and go back and forth. There'd be a time delay involved there. But now using the Cloud Security Monitor, we're able to pull in all that data really quickly, instantly. So here, Jason, click on a raw. OK. Let me move on to the next screen. So if you applied a filter in any of those stats boxes, it would go to the screen where you can see some of the raw data for it. Up here, he's got that blue one. That top one is selected. And so there's data down here that will be coming from that particular line. But you can see there's some good data that comes back in just the top section. The time the GET request came in, the host, the path, the client IP is the interesting one. And the policy ID. This might vary, or it might be the same for all of them. There's the ASN number. In the middle, there's this section will show what rules were fired. You can see there's an Akamai unknown bot, edge test, some SQL injection. So a bunch of rules applied to this. And then down at the bottom here, you can see advanced headers. And again, this is what you used to have to get logs to see, but you can see it right directly here. You can use these, as you can see, he used a curl to trigger off this alert, so we can later create a rule in curl and push it out to production. Really good, interesting stuff here. Here's the ASN number. Here's the policy ID, the 23852. Just real good stuff, and you can do it instantly. You can really do this under a minute. I'm going to go ahead and go forward. So back in Security Monitor, if you want to block that, you could block the IP address. So something we do pretty frequently is if we want a quick attack, we can block the IP address. We do that pretty frequently because it's an easy way to tamp down an attack coming in. But you could certainly do something more eloquent. You used to have to call into Acatech and work with us to create a custom rule using metadata, but we've now moved that onto Luna. So that's a trend, right? We're getting all these tools and we're putting them on Luna so we can share them right with you guys, so that you could definitely call us, or you could just do it via self-service. So in security configuration, you can see there's network lists, there's custom rules there. You can see there's a couple of custom rules that we've added, but we could add another a custom rule, or we can edit the existing one. And there's rate policies you can adjust, and you can decide what to do with them. And you can see the version up there is 26. That's useful for later. So he just clicked on security configurations, and this shows the versions that are now active. So version 26 here and 27, it looks like 26 is the one that's active in production, because 27 is inactive in production. That's because he just created it. He was playing around with it. So what you would do is, to block it, is you would do create version from 26, and that would create a version 27, which he's already done here. So he's just going to go and edit this one, and you end up with a 27 up there he's editing, but it's not yet pushed to production. So at the end of this, then, he'll do that activate thing in the top right to push it out to production and block the attack. So notice as he clicked on 27, it gave him this edit button here. So that wasn't there before, so he's able to edit this version and do whatever he wants with this. And here he can edit the client IP or custom rule, or he can build it out however he wants before he pushes it to production. And he also gets to tell it what to do. Do you want to alert? Do you want to deny the traffic? So there's choices there. What Jason will do is he'll create a rule, and he'll push it out to let me just check the time, guys. He'll push it. He'll just alert on the traffic because he doesn't want to deny it. Okay, so the plus sign at the top is where you could create a new custom rule. Those drop downs with the gear is where you could edit an existing custom rule. You could just change it. So here's where you'd add the rule name and the description. Down here, this is where we've moved these things onto Luna for you. We use the XML view if we're doing something really super complicated inside of Akamai. So when you click on it, it'll appear grayed out like this, but we can edit it if you need us to do something super fancy. Mostly, though, even we just use the structured view. This is the built-in onto Luna, reasonably safe to use. And you can now do almost everything in the structured view. It's pretty good. So we use this all the time. Here's where you could block IPs. He's just going to discard his changes. That's where you could block IPs. You could match on the policy and create a custom rule of some sort. Here's an example of a custom rule where he's filtering on the curl user agent. He's put in some rule structure where he's saying, hey, filter on the request header, how the request better be user agent where it matches curl, right? And, so he added a second one, right? And if the request header of accept language does not exist, because many bots will not have all the correct headers, or sometimes not in the right header order. You can see that that's a new option there. That was not there before. So pretty good. I encourage you to just experiment with this, because it has a lot of options and it incorporates a lot of what we do day to day in the SOC. It's very flexible and it's very quick. And it doesn't roll in any typos like the metadata does. I'm going to move on, I think. So he's going to do all of this stuff. And then at the top is an activation you could do. So here he's doing, as you can see, there's tons of choices there. There's user agent, all these other things. This matches, does not match, doesn't exist, exists, so on. So these are similar to contains. Pretty good stuff. Has everybody in here used Security Monitor? Everybody in here used WAF? Yes? OK. Should I show the going to production part, or are you guys good? I've got the last section about APIs. All right, I'm going to skip to APIs. OK. So he would activate this on production. Here's where there's a part where he's figuring out where it's applying to. So with network lists, you have to make sure they're applied to the policy. That's a common gotcha. I wanted to make sure I mentioned it. If you've got several policies, you want to make sure the network list you're using matches the policy of the alert that fired. OK. As you use Security Monitor, don't forget that we're here too, right? Call into Architect. We'll talk to Akamai. If you're a managed security customer, call the SOC or ask Architect to talk to SOC. We may have more tooling. In the example of WireX, we had an internal tool called EXA, which we examined on 100 different servers. Because we are spinning up new tooling all the time, we might have some advanced detection of some kind, and we might be able to help you more. So don't forget to call in. And this is the final section, of course. This is about our APIs. I think APIs is going to be a big growth area this year. I think that it's going to be really easy and prominent in security. I encourage you to go. You're in the developer zone. I'm sure you're all on developer.akamai.com. already. It uses Docker for the rollout, so I'll skip that. There is a security monitor API. You can download report packs, and you can block things using network lists. And that means you can block client IPs, you can block entire countries, you can block France if you want to block France. And you can retrieve real-time data on security events, both in Security Monitor on an Akamai's Intelligent platform and on the Prolexic and Routed platforms as well. To get there, you'd go to developer.akamai.com. Next to the Get Started, you'll see the APIs, and there's examples of APIs there. This is the cloud security. The section you'd want to look for is right here, Security Monitor, and you can see some of the APIs here. This is the resources. If you go to the Resources tab, it starts to show some examples of those request parameters. It gives good examples of them here. So this is a request of getting report packs ID, data, start date. This is this is an example of someone fetching a report pack with a certain start date and end date and sorting by different parameters. It gives real good examples. These work if you run them. And I know that because we just did it Monday. Parameters, on the parameters, it tells you good details about what all the parameters are for each one. Filter, these are those stats by boxes. You know those 4 stats by boxes we showed? These are where you could say, does it contain this, does it contain that, does it equal, not equal? And so you can start doing filtering matches in there. This is an example of the response that would come back. So there's examples of the response that would come back. This is saying columns times the time description, country from which it came from, and so forth. These are some of the APIs. What you can do, you can list report packs. You can the interesting ones are you can list report packs. You can get a data store, and you can get a report. I mean, you can do all of these, but I think those are the interesting ones. This is an example of getting report packs. You want to get the report packs because you need the ID. If you get the report pack back, you'll get that ID number, and that's going to be key to your other calls. I know I'm going kind of through this quickly, but it's all in developer.akamai.com for you. You can list the data stores in the report pack, so there's report pack ID there. Once you know it, you can put the report pack in and get the data stores. That comes back and looks like this. So I use that report pack ID there, and I've just added /data stores on the end of it. And then here it comes back and says, here's some data, some detail about the report as it comes back. You can get a report. Now that you've got that information, you can get a report. So to get a report, you need to know the start date and end date. Maybe that'd be today. Maybe it includes the date timestamp. So maybe you want the past hours worth of data or something similar. You can specify certain dimensions, and all that detail is in the parameters. So here's an example of that. I've set my report pack ID. I've set specific dimensions according to parameters and metrics, and that's my query. And I might get data back that looks like this. Here is some of the columns, unique IP of the user dimension, and it starts to give the IP address and number of rules that trigger for that client IP. Listen, I know this is all data, but I'm really excited about this because it means that in your SIEM, you can program an application that interfaces with our security monitor data and provides that information out to you. We've got several customers that are doing this now. They can either display their own graphs, or they can do whatever they want with that data. They could correlate it with other points of monitoring within their own data centers that they might know about. And they might say, well, a spike over here, but it isn't actually hitting our database, so it's not worthy of our attention. Or a spike there and on our database at the same time is worthy of our attention. They might want to do something with that automatically. We certainly have one customer that's using this and is then automatically pushing a block out to the internet to block to WAF to block that user from hitting our edge servers. Here's some of the IPs coming back from that query. So that's on Security Monitor. You can do the same thing. You can do even more, actually, on our legacy dedicated security network. You can do even more because you can not only get all the statistics and all the packets, you can also receive alerts. So you can inbound alerts right into your SIEM as well and have them pop up. And so you can see those. On the Prolexic, then, this is the Prolexic API summary. You can list events. You can list critical events. So that's different than Security Monitor. So here you can actually inbound alerts as well. And then, similar, you can list the metric types and get attack reports on Prolexic as well. Pretty cool stuff. I'm really impressed by this, and I think it's going to be really popular this year and going into 2018. This is an example of someone listing the events in a contract, a sample contract named Sport Index. And this is saying that the contract exists and there was no data in it. These are the network lists on Security Monitor. So you can run an API and pull in the network list and with some information about the network lists. This is where you might automatically block an IP out of Akamai's edge, right? You can list a network list. You can create a network list. I think I really don't recommend creating a network list using the API, but you can, because you want to just do it manually. But you can modify an existing network list, and this is used all the time to go ahead and add an IP address to a network block. So an example of that might be you can get snapshot. You can also get the status. I don't know where the status was. I probably skipped over it. But here is an example of see if this network list exists and if the IP. This is an example of how to see if you've already blocked it. Have I already blocked this IP? I can give it an IP address and say, hey, have I already blocked this? Yes, I have. No, I haven't. So it's a way to automatically query Akamai service to see if we already have blocked the IP address. And this is what might come back from that. It might say, yeah, I see that IP. It's in the whitelist. It's already in there, and it's not on production yet. You must have did it 5 minutes ago because it's pending activation. This is really true automation. It's good stuff. So that's it. I want to point you to developer.akamai.com where all the parameters are. I think this would be fun to go through to start to get sample data. We certainly had a lot of fun with it last week as I was showing a couple of the specialists in the Cambridge office. All the data is there on developer.com under cloud security. So that's my presentation today. I want to continue our dialogue. I'll take your questions now. I'll be happy to answer them. But also, again, I'm on community/cloud community in the cloud community there, and I'll be happy to answer, as well as you can make friends with each other and help contribute to each other's questions and understandings. Overall, though, our Security Operations Center is in it for the long haul. We consider it a battle, a war, not a battle. We play it like a chess game. I think that you should partner with each other for security and with us, and we'll continue to work with you. We are definitely proud to be fighting the good battle on behalf of our customers. Thanks for listening. Can I answer any questions? Thank you.
Security Monitor, when you're looking at the raw data, so up top you'll have all the events, and then the request and response down below. Is there any way to, so let's say you have it all filtered down to tab traffic, you look at the raw data, any way to identify like the common threads amongst all those events aside? So right now we'll go in and then flip through and you're manually flip it back and forth to say, okay, is this user agent string unique, etc.
Not super easily. We just have those 4 stat boxes that you can put different data in there, and you can represent them slightly differently to look at them different ways, and that's as good as it gets currently. Yeah. However, you can download the data too in a spreadsheet, and then you can sort it 6 ways from Sunday, if that helps. I'm still an awk and sort guy to this day, so I want the long awk command line. Anyone else? Yeah, go ahead.
During your times at Akamai, if you could share one of your biggest attacks, and during the mitigation, some things you did right and some things you did wrong.
I think the 622 gigabit one was our. Go ahead, sir.
From my perspective, when we went back, because we're an ITIL house, we do continuous improvement assessments constantly on all failures. And we deem anything that takes more than 15 minutes of failure, even though it's a success technically, right? So we could have absolutely been faster in managing the internet. So I don't know if you saw some of the other presentations, how this year we're at, or next year we're adding several more scrubbing centers. We don't need it for more capacity or more ability to handle larger attacks. That happens to be coming along with it. It's actually to give us more physical diversity, because a lot of our customer pain has now gone away from an attack perspective, because we're really sharp on that piece. And it's now, when I look at the types of a problem, it's, oh, there's a fiber cut 3 hops away from me at a carrier I have nothing to do with. Yet, I'm now the customer edge, right? So now I, with these extra services, will have the ability to move your traffic out of certain geographic areas and still take it in elsewhere, right? So my lesson learned with that, specifically to answer that, is well, we took a deep breath and said, I have this from a security perspective, and we should have stayed more diligent on the network management perspective, even though it wasn't, it is some region.
When do you, at that point in time, when do you delegate to the network people? I mean, so who takes that?
Yeah.
Who comes and say, hey, this is a network issue? Is it a network team? Is it security?
So the SOCC is broken up. My team's broken up into several areas. There's triagers on the front end. There's the security people that are in the middle. Every one of the security people has to know every product well enough to operate it, and there's subject matter experts from there. That one would have gone to the subject matter expert that have routing skill. As the people that have high security skill, I have people that, the GIAC, the CCIE. So I have several CCIEs on the team. We should have routed to that. So we don't have to delegate it to a different team in the infrastructure that's network only. We actually have that still by design in our team. Where my limit stops, and I do have to give off, is if there's gear issues. So there's hundreds of pieces of mitigation gear, all different types in every single scrubbing center. If some of those start to fail, that gets delegated out to a different group that does the rack jockey work at that point. So we're fully empowered to address the vast majority of issues tactically within the SOC.
Now, you mentioned that there's, with this failure, like 3 hops upstream. What kind of tool do you guys use to kind of see before things come to
So there's several things that we do. Obviously, there's some manual things that you can do. Anybody can do. But we use some tooling that can look out. We use Thousand Eyes as one of the guys. We don't use Thousand Eyes to monitor our infrastructure. We use it to monitor the general health of the internet. Right? So we're using their nodes, their node to node, and then we place some close to our service or some not to get a feel. And that automatically tells, hey, Telstra or Tata or Level 3 or whatever it happens to be, they're having some issues in this particular region. I can't even, my challenge, I can't even open a ticket with them if I don't have a direct relationship with them. Right? So if it's NTT or, so those people that I have a direct relationship with, we can get that taken care of right away. Because we're contracted with them. That's one of our carriers. But obviously, the guys are going to be doing just a bunch of the standard lookups and time to lives and traces that they can do, and then we take that back and let the customer know what's happening.
Sure.
Thank you, Mr. Branco. Is in our Fort Lauderdale location, so he knows all the router ninjas down there. Yeah.
If anybody's
Yeah.
ever in the Fort Lauderdale area, you're very welcome to come in and show you the SOC directly.
Anyone else? All right, well, thank you very much for joining. I'll see you on Community. Thanks, Elizabeth.